Okay, so thank you all for coming. I think I'm pretty commonly here, so I think a lot of you know me. But I'm Scott Anderson. I'm a data architect at a place called 66 Degrees that doesn't have an office here in town. So I'm like a remote data architect, which basically means a data engineer who's expected to put in a little planning before he starts going and building things. Is all that all that really means. So going through go through today, kind of if we take a look at the agenda here. So there's an entire data landscape out there that I think people aren't really aware of often when they first start getting an idea that they might want to get a job in programming per se. And so we're going to go through what that is, what you actually do if you get into it to the best I can found that very difficult question, and how you might be able to get into it, whether you're looking to get in from school or other industries, or if maybe you're interested in taking an existing programming career more in this direction as well. So, okay, so let me put up here. So this is what, like, when I had some idea, I don't know, like a dozen years ago, that maybe I wanted to be a programmer of some kind. This is about, what I figured was out there. I mean, I knew, of course, there were apps that ran on my computer. And, but pretty quickly you realize, like, oh, what people are hiring for is very much jobs in web applications. It's, far, far larger than the job, applications on your computer, right? A lot more web programming out there. And then obviously there's a game subset, which if you start looking down that path, someone should tell you early on that is a lot harder, and the return on brain damage is lower, such that, good luck if you get into it. But even if you get into it, you may end up criminally underpaid for what you had to learn to get into it. Would at least be, my review of that.
This is for web apps?
Maybe I should make this a bit bigger, but this slide is basically saying, before you hear about the data plane, in general there's an idea like, there are desktop apps, but most of the buzz is around web apps, and there are jobs in a few other things like games, mobile, and there's like in-front ops jobs you probably come across as well as, what's out there. Turns out there's a whole nother plane of programming jobs out there in data space. So, and this really is, I don't actually have numbers on exactly how this compares, but and there are definitely some jobs that hybridize between the two places, where there are people working in applications that maybe kind of start on the website and pass data to things that become data. We'll get into how data is typically ingested in a bit here, but this is a very large space with a lot of jobs in it and a lot of different roles. But the main roles kind of compress into these three different ideas here. There's data analysts and data scientists, or data analytics and data science, by discipline, where basically what data analysts do is they take reasonably well pre-processed data and either make SQL reports or things like Tableau or Power BI dashboards off of it. And there are data scientists who take, pre-processed data and feed their data models with it. And in both of these cases, these professions on the right here are expecting data that is going to be reliably accessible and updated, and not have some stupid new thing pushed into it that breaks the whole thing overnight. And so the way we get there is what we call data engineering. And so now the interesting kind of good news here on the data engineering side is people have different opinions on this, but what it means to say a data science job is a very strange thing right now, especially with LLMs and all that going on. But in general, data science could have been argued to have been saturated before LLMs, and now everyone shares in LLMs. So I don't want to get into a big holy war about how we, score that one. Data analytics is, probably, a more normal job market. there's still a lot of, I get a lot of blind reach out for data engineering still, and I mean, I think by far there's, more of a supply-demand imbalance on, please can I get some data engineers in here, relative to these other two. So that does mean, like, hey, if, we've been looking at, maybe doing web programming or something like that, and then finding, like, that got really saturated, and then the interest rates went up, et cetera, and people started laying people off, et cetera. Well, there is a space here that does still have a big supply-demand imbalance. But in order to, we have to figure out what it is if you maybe want to do it. So let's go through kind of, what this is from a top-down standpoint first, and then we'll get into like what you actually do. So enterprises have a bunch of data spread across a whole lot of data stores in many different places, many different data centers, across different data, platforms and locations, etc. So spread all over. And if they can get it all in one place, they could probably generate a lot more insights out of what's in the data. Now, I mean, in order to actually get it all in one place, I mean, when I was like in high school or college, a new video game came out. I wanted it to run on my computer, so I had to scale up my computer so that it had a bigger RAM and disk and CPU to run it. But at a certain point, you can't just fit it all on one machine. So instead, you have to be scaling across a bunch of reasonably priced computers instead of trying to buy one really, really pricey one that, by the way, would probably just fail anyway. It wipe out all your data. It's a whole other thing. The way this is, this is something some of the larger organizations early in the earlier days of tech all figured out, but the way that the industry sort of inherited really came from Google, just because Google eventually just kind of said, there's been a lot of interest in how, we did PageRank, essentially like taking and ingesting the whole internet and asking like how much each of these pages are linked and that sort of thing. And those involve some pretty big compute jobs and storing the internet in a way. And so, people started asking, how on earth do you do that? And eventually Google said, all right, you know what, we'll tell you. And so in 2003, they put out a paper about how they store all of this data in a fault-tolerant way, scaled across, again, a bunch of sort of commodity, cheaper computers that you could just have hundreds of them out there and that kind of thing. In 2004, they told us about MapReduce, which is essentially how they run a job across all of these different machines, and it doesn't really matter if node number 74 loses a hard disk midway through, and just gets separated from the network or something, like rack fails in the data center or something, because essentially a job manager just says, yeah, go redo node 74's last work and just proceed without node 74, and then it doesn't all fail. So because Google told us how they did all that, and a bunch of talented Yahoo people went and put together an open source version of this called Hadoop in 2006, a lot of that heavily influenced in it, the tools we actually use to do this historically. But then, now we have this thing called the cloud. So before, you would have to actually go and buy those, in the case of Google, many machines. In the case of a lot of enterprises, we're probably talking more like tens, until you get to like really, really, most people don't have that large clusters, right? But, what the cloud allows us to do, and what makes this both in a way more fun now, and that you can do things at crazier scale, but not have to like buy for always having the crazy scale. You can just borrow as much compute as you can actually efficiently use for a batch job, get it done, be charged by the second, and then just yield it all back. And it is your hyperscaler, your cloud, your Amazon, Google, or Azure's problem to go and resell that. And so that means there will have to, like, let's say, even say you have like a big, say, test suite, for instance. You used to, if you wanted to have, an ability to scale all of that up on demand, you would have to have had, available, space in your data center for that. Well, now you don't. And so instead of having idle space for that, you just kind of check it out and say, yeah, okay, excuse me, we'll choose that. But so that's the first big win. But so in here, we're kind of imagining like, okay, I can go from having, 1 to 75 to 5, computers running it well. But a lot of times, I probably have a fixed amount of data in my system at a given amount of time. So what gets really neat about this is in the old model, you were essentially scaling your CPUs, your memory, and your hard disk. With modern cloud, you can just say, actually, I just want to scale compute, and I'll just scale my storage completely independently of that as I load more data in. And you can do that, your hyperscaler just charges you for whatever you use now, which makes it a lot easier to do things at scale now. It also does make it easier to accidentally run out big bills, which we'll talk about in a second. So then what is data engineering? Where do you fit into this? What would you actually end up doing if you get into this? So really, we've smashed together a bunch of different job descriptions that existed before, and we just kind of called it, about 12 years ago, we just started calling this data engineering, because in the cloud, these things started overlapping so much, but in reality, there is no data engineer job description that's going to be consistent across, you look at, this job with, some shoe company, and you look at this job with some, electronics manufacturer. Those are just two manufacturers in my mind. It could be, very different depending on parts of the things you look at. But I'd say the three kind of core things here. So ETL developers, so people focused on extract, transform, and load logic of taking data from all these disparate data sources and getting it loaded into the one place, is definitely one of the core parts there. Data modeling, turning this into data that is joinable in a uniform way, and that's funny. Intro talk. I'll talk about Kimball a little, but so dimensional data modeling, essentially separating your data into where you have nice long sequences of facts or observations about something, and storing those with key-based SQL linkage to tables where you have all your categories you can associate with that. We have a bunch of categorical data you can assign to that data is,
So what does that job look like in the data modeler?
So that part of it is really setting up the tables you'll be using at, typically it tends to be setting up tables you use at different points of the process. And I bet, we can kind of, let's just kind of replace going through these and kind of talk through what this might look like. So ETL guy dumps the tables from, say, an MS SQL Server database that someone had upstream. It's in a bunch of tables in third normal form, and then someone also just happens to have some, we could say something, really fun and spicy, like some IoT data streaming in, or we could just say someone has this boring, updated once a month spreadsheet. It could be either of those you want to use together. You'll probably first make a table for each of those that sort of rinses or cleanses each of those, saying, one on editing these to remove any data error issues, coerce them into data types you use, and coerce the fields into things that kind of align with how your data warehouse uses it. And then you'll be, I don't know if I want to get into denormalization in this talk, but you'll probably have to adjust the way those tables were coming in from MS SQL Server from a way in which they were designed for really fast individual record lookup and making sure you don't duplicate any data or do anything a little off. And I'm trying to avoid saying referential integrity. I'm trying to define it on the fly, but so the upstream system will be designed with it's not really meant for like big data crunching. They'll be turning it into a format that you can partition in a way. I'm assuming it's big in the first place. Sometimes it's actually small, and you don't have to care about all of this, to be entirely honest with you. But yeah, if you put those together, VBA is database administrator, and also you feeding things forward to models like ML pipeline is kind of part of all of this kind of comes together now. And a data engineer on a given project is never doing 0 of these and never doing all 6 of these. I would say in general, or if you are doing all 6, you probably should be having some conversation about teammates and also maybe redundancy if it's generally assigned people aren't together coverage on that. But so yeah, broadly speaking, you'll be making a series of tables that make the data both more reliable and able to be queried downstream in a more performant way. That's what's common across all the patterns, I would say. Let's see. Any other questions on this side, I guess?
I haven't heard the word Kimball in a long time.
Yeah, well, you don't have to do the date dimension anymore, right? Like if you actually do pick up like an old school data modeling book and whatnot. Yeah. Yes. There are some things that we've found ways to elide, and in fact, that is a good point. Like, people generally do still send you to that book. It's generally just called Kimball, not the Data Warehouse Toolkit, I think it's called. And I mean, if you do just open up that book, especially if you tried reading it in any kind of sequential way, you'll actually pick up a bunch of stuff that like someone should just like. It'd be better if like a more like modern data engineer just took like a red like ignore stamp and just stamped like the first like several chapters particularly early on in the book should just be stamped ignore your modern data platform will do this for you. You should never write a date dimension by hand again. I mean that's just no.
You have to have a dimension for days, a dimension for months.
Never again.
Never
again.
I'm glad to hear that.
Right, so trends in the tool use. So historically, there was a lot more Java or at least JVM languages in this. Everything is trending in the direction of Python and SQL. So on the ingestion side, expect to see a lot of Python. You could still see some Java-based things. So I mentioned the Yahoo implementation of Google's open source stuff, the Yahoo open source implementation of Google's things, rather. So that was all a Java-based thing. And there is a kind of legacy Java presence, under the industry in a lot of places. We'll see a bit of that in just a second here. But so in general, I'd say at the ends of the data warehouse or lakehouse, we keep making things more fancy, but you'll see the more procedural code, generally Python, a lot more in the beginning of the pipeline and ingestion side, and in the like, oh, I want to feed an ML model, that kind of thing. There's exceptions to all of this, but the trend, by and large, is to get the data landed from the source with as little T and ETL as possible, and instead do ELT. I feel like they should have made this compatible with the common sandwich that I need a B for. So in other words, extract, load, transform. The idea being get the data pumped in a really, really bad looking state into your SQL lakehouse, and write a bunch of bad-looking SQL that turns it into the pretty stuff instead of trying to transform it mid-flight. And the reason for that is if there's, issues with, ingestion, you have to recreate any of those steps you did in order to get that data re-ingested. And also, candidly, you can probably just throw more SQL developers at it. Like if you could get like pure SQL developers that are kind of like demi data engineers, like that'll actually be cheaper. So, you know, if you can throw it, the more you can make it a SQL exercise, the more you can. Having to write, you know, non-SQL code is, from a business perspective, is going to cost more money, which as a data engineer means you want to be on that side. But mostly, you know, Java's paradox, you don't want your job to go away. Yes.
Sorry, so to summarize, are you saying there's a trend to move some of the computation from the transform step to the load step? To
get the load.
Technically, we say there's a way in which you can kind of say that, but we think of it more like a switcheroo. So we think of it like, in other words, you can think of the ETL becoming EL, like transforming as little as possible. In practice, you'll still probably be, say, appending some new timestamps in like some new columns, that kind of thing. But in general, not messing with like the core data, not actually transforming that stuff. And so, an example, you know,
is this related to at all like a data lakehouse or warehouse where you would keep a copy of the messy data that you ingested as part of like your load, and then later on you would clean it up?
I will have a messier initial messy table, and then I'll be doing more work in the data warehouse to make that transformation. That's the other thing.
As opposed to front loading the work during ingestion.
Right. And so a way to visualize this is like, I mean, I know we're kind of all levels in here, but I mean, hands up if you're familiar with JSON. Hands up if I saw a date expressed in JSON, how should it be expressed?
We will go to battle over that question.
I mean, I'm hoping it is represented, particularly if I have a date time to seconds, for instance. I'm hoping it's represented in epoch seconds.
Yeah.
And so, right, and so
Epoch from Greenland.
and so kind of the more ETL approach, you know, might have been, I'm going to read that integer of an epoch seconds timestamp. Epoch seconds being amount of, for just coloring it in for people, is the amount of time we basically keeping track of what date time is, the amount of time that has passed since the beginning of 1970, or is that
And different.
I actually don't remember, but
Are you talking about Unix UTC timestamps?
yes,
Yeah, it's like since 1970.
yeah, I think it's Jan 1, 1970.
Yeah.
And so in the ETL way of thinking, it's, oh, I should take that integer of the number of seconds and turn that into, say, a UTC-based string timestamp for this table, and, you know, load it as a timestamp into that table. The more ELT way of thinking about it is, you know, in the JSON, it's always going to be an integer, it'll load in automatically as a long integer, you know, add an extra byte kind of thing. Just go and plop it in there in my, you know, really ugly bronze, you know, ugly raw data table like that. And I'll use a SQL function to pick up the epoch seconds and turn it into the timestamp in the appropriate zone, which should better be UTC or you're in trouble.
Did you say?
You want to be able to check that off the list. You want to say, the extract happened, we're done with it. The load happened, we're done with it. The transform, we keep deciding what we're up to in that space. So you can't be done with it.
Right. Yeah, so that gets, so on the transformation side, I said, you know, what's going on in your SQL warehouse, you know, doing all those transformations has, you know, trended more SQL over time. And, you know, SQL been around since the 60s or something, and not going anywhere. But, you know, that's fine. But where if, I did a version of this talk for the Python people recently, and so I'll say, you know, if you're looking for not just the SQL part of this, all that stuff has to be orchestrated, and there are some, materializing these tables, because you don't just, you know, make a string of like 20 views on big data to, or it turns out it takes a very long time to get anything back, so you materialize or save out a copy, you know, say on a daily basis in your, you know, lakehouse of, you know, what you're providing there. And in general, orchestration of all of that is going in one of two directions. Either you handle that in Python using tools like Airflow is the leader, and Prefect and Dagster would be alternatives, or sometimes you use something that's like embedded into one of these platforms. There are ways to try to like not even have to do it. But yeah. So, PySpark. So, lingua franca for the industry on getting data between two like totally different data sources, not relying upon any real, common features between the data sources. And so, I guess, who's heard of PySpark before, or who's heard of Spark before, I should say? Good. Oh, more than I thought. Okay, good. Yeah, so, now, where this kind of fits into that, I said in 2006, Google's way of doing things got open source. The way Google was doing this is you have to break all these jobs down into these tiny little steps so that you can broadcast them across hundreds of machines. The original how to MapReduce calculation way of doing that was every step got picked up from the shared disk space between all those computers and written back to disk afterwards. In 2012, someone said that's insane. We surely could keep some things in memory and just say like, okay, if this one gets done with this, it could go into another, a following job state that uses, can take advantage of the fact that I already have this loaded in memory, and I have to save this out to disk, because that actually, not just from a performance perspective, when you're talking about like HDD platters, that actually wears out the disks too. I mean, they are like always writing them, and that increases your failure rates on the disks like a lot. And so, Spark is basically what has been gained popularity since about 2012, when someone figured out let's keep it in a way to keep it in memory. And so what it is in general, data engineers now will be writing PySpark code. Spark, the underlying framework, is written in Scala, which itself is like a functional programming version of Java that is beautiful code for this sort of thing and is actually really aligned with what is happening under the hood. I actually loved writing it, but our HR people have told us, and by our, I don't mean my firm, I mean the industry's HR people eventually have told them that they can go and find Python developers a lot cheaper than this esoteric Java variant called Scala. Even though really, if they could have done it, they could have been retrained. But anyway, so now what we do is we write the Spark type code in this Python dialect called PySpark, and we just transpile it into JVM code under the hood. And so you actually see this when you fail. You will get an error message, and it will be a Python error message, a Python stack trace, followed by a JVM Java stack trace. And both will be honestly unreadable. I mean, it's really, there's definitely a skill toward, getting used to how on earth these work, and you have to understand some things about how the data is actually being distributed under the hood to understand these. But, it will help you. Eventually you can parse through the error messages and get there. So, thank you for cranking it. How am I doing on time?
We're at 2:30. Well, I was going to ask a question, but I can save that for the end if we're concerned on time.
I don't have that. I can kind of go through. I'm going toward advice mode here in a bit. What do you got?
No, I was just going to ask, have you ever heard of anyone using WebAssembly instead of the JVM or PySpark for some of these data processing jobs, or is that still esoteric?
We instantly need access to outside resources.
Yeah, don't want to touch that.
You don't want to touch it, or you haven't heard of anyone doing it?
I haven't heard of anyone doing that, and I'd be very surprised, because there's some. So a lot of this, you have to look at how you're networking this with.
No, I mean, I think there are a couple products that do it already, where it's just instead of writing the Python compiled to Java, it's like a subset of Rust compiled to WASM, but it's the same thing.
So the point of this here is that there is a big cluster already set up to accept Spark jobs. So, if
Yeah, it's just
cluster
it's
set up
just
wasn't
different.
great, but that's,
Yeah,
if there was a reason to target that, I'm sure things could be transpiled for that, but,
no, it's just like a different thing, like vector.dev. It's just some Datadog product that just uses that instead of, it's just a Spark alternative.
I haven't heard of Datadog, I haven't heard of that, but, yeah.
It's,
Yeah.
that's still going to be very, very, very niche. PySpark is where it's at.
Probably. And there are some alternatives that need to be more real time, et cetera, but, intro. So if you look at like, hey, how do I become a data engineer? You're going to see a lot of charts or maps that look like this, like all this that map. People try to say these are all of the like open source technologies out there that data engineers should know, and obviously no one knows all of these, but not at all. And so really, what's not important is knowing, Cockroach TV or Hootie or any of those. It's knowing like, okay, there's this idea of a data lake platform, and within this, there are these idea of open table formats. I know Iceberg. If someone's using Hootie, I can figure it out. So being able to break them, just understanding why they exist, and having experience in something that's at least in the teal box, if not in the particular column in that particular example, for instance, is really what you should be. Should make you feel like you're heading in the right direction here, because you can't learn all this. So going kind of modern here in the cloud, a lot of what was on the left side there was a bunch of open source ones. Cloud providers make it interesting. They also kind of want to have you locked in so that you can't move off as easily. There's some pluses and minuses here, but in general, people are going to continue to go in the direction of cloud-based services because of the separation of storage and compute we were talking about earlier. There are ways that you can use the cloud to run your own sort of like managed Hadoop cluster in the way we were talking about that being laid out earlier. There's a lot of work involved in that, and so in general, I'd say firms go in the direction of use some other service that kind of abstracts more of that away so that I can have less ops people or data ops type people who have to take care of those like individual servers and that kind of thing and more. I just want to submit a job, man. I just want to submit a job on a compatible runtime. Please God, I just want to submit a job on a compatible runtime. And so just kind of the biggest players here. So Amazon, the biggest cloud. They have Amazon Redshift as a lakehouse solution for you, but a lot of people just do things on Glue, a managed Spark service on Amazon, and just drawing tables over S3 buckets like ephemeral tables, Athena. I probably should put Athena up there as well as part of that sort of ecosystem way of doing it, but a lot of different ways of doing it. If you want a more traditional data warehouse type experience on Amazon, you can use Redshift. Snowflake is kind of Redshift 2 years in the future. So a lot of people will use, the point here is you can use what comes with your cloud, or you can use a specialized one. And yeah, Snowflake is just this one 2 years in the future, basically. There's a history in which that's not true, but the choices Amazon started making for the past 4 years, they used to have a completely different architecture, and now they basically do about the same thing. So a lot of people will, if they're on Amazon or Microsoft, particularly if they're on Microsoft Not Fabric, they'll choose one of these, Databricks or Snowflake. Whereas
people on Microsoft with Snowflake, so both. That means you can have Snowflake anywhere.
Yeah, I think you'll go on Azure in your case, and you'll separately sign a contract with Snowflake, and then you can still you'll have your secrets stored in Azure Key Vault, for instance, and your you'll upload binary like blobs of JSON or Algro or Arcade data to their bucket storage, their Azure blob storage containers. They have an extra. We've always an extra click in Azure. Don't get me talking too much about Azure. People tend to choose Google for BigQuery. So if you're on Google, you're probably using BigQuery at least in part. But yeah, the idea here being that you can be on one but not use its underlying parts and buy a sidecar essentially.
So all these kind of usually like proprietary, like somebody would need,
Yeah. Now
people, if they wanted to learn one, they need to find like a free trial kind of thing?
we'll cover that in just a moment
Okay.
here, but yeah, these are all like proprietary things. That said, like Databricks, you can really feel the Apache Hive and Apache Spark underneath the hood. Snowflake tries to make it like easier to not see that, but I mean, you will see a lot of these technologies, from that kind of age from that, sorted Java history. You'll see a lot of that stuff under the hood. A lot of the stuff is actually kind of making these work in the background. But yeah, we'll see how you can actually get started dirt cheap in just a moment here. But I just wanted to say on generative AI here real quickly. So if you're thinking about this in terms of getting a job or, either getting a job or perhaps, moving into this, but if you're concerned about like supply and demand in the market and you're thinking about Gen AI and our jobs and all that kind of stuff, the good thing about the data space relative to the web dev space is that while we still have the same thing going on of like our day-to-day jobs, many things that took hours might just take moments now and just get Gen AI to do it. We share that with the web dev people, but we also have entirely new tasks now of using these LLMs that fall within our purview, such that like I make data pipelines now that ask, in my case Gemini because I'm in Google End, but that ask an LLM like, hey, I want you to take in this say medical device here. I can't give too much away. They got, but this sort of device in a product inventory. It has a description. There's a bunch of abbreviations in it. I want you to take a medically aware LLM and convert abbreviations into the words that they likely are. And then I want you to sort this device into one of these 7 categories. You can have LLM steps that do that in your data pipeline. And so that's like net new work for us. And so, I mean, in general, it's been my opinion that, a lot of firms are probably something like 2 or 3x overstaffed for what they actually do in programming space as it is, before all of this. And so there's some ways in which I don't expect LLMs to actually change that. I just expect, there'll be people who do more than, there'll be people who get a ticket assigned and only do that on the day and maybe get the ticket done right and maybe don't, and there'll be people who get a ticket assigned and ask if maybe they should be doing something else when they get the ticket done. But I think there'll remain enough of those people that of the former type that there'll still be a bunch of unfired fools that slow down. I don't see similar to how there will be a bunch of PowerPoint assemblers, even though they'll actually really just work an hour a day. Someone just has to be responsible for saying like, yes, I will get this done and that kind of thing. And all of those things, those flows have to be re-architected. I see plenty of employment for a long time, but for us, the good news is, however that Jevons paradox argument lands on, programming is cheaper now, and we can get more out in person. We actually have net new work here, so that's good if you want to have more demand for your skills. So I say that this has been easier to get into than, and particularly, than web, easier to get into than web harder to get into, more barriers to entry, but that there's more jobs out there. So easier if you learned it, that is. And so, yeah, there's barriers to entry to learning this. And so several things here. Big data concepts do not replicate on your laptop. Like a lot of this is, well, okay, so I have, literally hundreds of sensors sending data from this factory floor. Even if my laptop was configured as like, if I could just slip on a thing to go and receive all of those, I mean, really, that's actually multiple servers need to be listening to pick all of those up in a partitioned way and store them, for instance. You're not just going to run something on your laptop and do that. You also generally tend to have a bunch of proprietary things that need to be emulated, or at least even if it's not proprietary, you have to be like Docker running a bunch of stuff on your own computer. I mean, that's kind of how many people use Docker in like their first year of learning programming? This one might be better now. Most people probably didn't. People definitely didn't when I was learning. If you used it, you might. There's a lot to learn in Docker that usually goes beyond using it proficiently. Is usually not something we would expect out of someone who's trying to break into the industry for the first time. That can be hard. So with all of that, I can't just like try out my website on my computer and see that, oh, hey, it's actually working like the web devs can. That's historically made it harder to get into this. But cloud makes it easier, but as we talked about, cloud also really wants to scale on you, so it's kind of dangerous. You get a big bill. So here's kind of the recommendations here. So there are two things people mean when they say free tier in this space. So, Databricks and Databricks, we know about this recently. AWS now has one, but you can sign up with Databricks. You can just go to their website and say, I want Databricks free edition, and you can like not bother putting in a credit card or anything, and use Databricks and not get charged until you say, oh, I actually want to like upgrade my account. And I mean, you have to pinky swear you're not doing it for commercial purposes. Watching you. I mean, you can learn Databricks with, most of its features just on low compute power for free and not worry about cost overage. Similarly, so historically when, the clouds will say, we have a free tier, and they'll mean, we have services that we'll let you do 1 million calls on this service for free each month. But if you go over that, then you just happen to go over that and we start billing you, and there's not a kill switch on that. So that's how GCP, Microsoft, and some AWS services work. However, I'm told by our friend David Hoover that AWS has a totally free sandbox one now that I just pulled up briefly. They're like, you can. There's a no foot gun AWS option as well. Being GCP, okay, fine, whatever. But you can do that. Now I will say, if you do have a little more experience, the fear is good. Maybe learn how to do it. If you are coming with a little bit of cloud experience, challenge yourself a bit. Right, but Databricks and AWS, easiest to get started there. If you want to be in a totally free sandbox, you don't have to worry. I believe on Azure, for Fabric, they'll only give you a time trial. Same for Redshift on AWS, I know they'll only give you a time trial. For instance, Snowflake might be similar. I can't actually say on Snowflake. 5 minutes? Okay. I think I'm close to the end here. So, I just want to talk a bit about, for people who are looking to break in here, just kind of differentiating yourself, and so you should probably build something to talk about. So in general, so the industry bloated a lot on these, what do you call the boot camps, that sort of thing. In general, you're not going to get a job just off of a boot camp, kind of breaking into this sort of thing. That said, there is there are exceptions if you do a data engineering oriented one, maybe. But so boot camp, you probably need to have a little more. And so what I really would recommend you do with one of these free edition things, if you want to break into this, is find some data that's available somewhere online. Whether it could be like a free API or something that you have to web page scrape, assuming that you don't get kicked out of the web page scraping. Build a program, yeah, that is getting harder over time, I'll admit. Build a program that'll ingest it into something like Databricks Free Edition. Clean it up, kind of like, what we talked about, land it, and then, really you just need to be able to tell, a recruiter and other data engineers, like, the data was like this, that I needed it like that. That's really what you need. And then please put the code on GitHub. So I sift through some resumes, that's kind of like a second filter. I did more of it in my last firm than I do at my current firm. And basically what I did on people who were looking to break in at junior level, if I see boot camp, I would look if there was a GitHub repo anywhere on the resume, or if there's anything that suggested. If I didn't see anything that suggested something to like a way that I could see some code they've written or something very, very quickly, I would go on to the next one. GitHub. Get a GitHub, or failing that, at least, and you can do both, if you can get data on a dashboard. So, if you can take a thing like Tableau, they have a public version you can just post things on for free. And as long as you're fine with it being public. And if you're looking to get a job, you want it to be public. So that's actually a pretty good synergy. So, make a dashboard, feed it into an ML model, put code on GitHub, and make something publicly accessible. Honestly, another thing, that's right, I put this on one more slide here. So, I hate that this is a thing, but cloud certifications, they don't measure the right thing, but a lot of firms in enterprise actually do like it, in part because it's an objective baseline, and if you do ask, if you ask 3 people to go get it, and 2 can get it and 1 can't, well, something you're wrong with that guy, and there are some issues, some people take tests better, etc. But it doesn't test the most important stuff. It will help you get a job, assuming that people you have in that are in the cloud. Also, personal website. So this is another, I would say, if you're I don't actually have a personal website up right now because I don't really have anything up I really want to talk about per se, and I'm not really in the job market, but you could get a personal website that's not on your own, I paid for this domain. You could just make one of those with an LLM over the course of an hour. It's actually not that bad.
And you can host it on GitHub pages.
Yeah.
And it'll directly deploy from your GitHub project.
For free.
And you can make it a data dashboard, by the way.
Yeah, you can do it. Yeah. And honestly, in data engineering, I talked about how, just get all these different varied challenges thrown at you and you don't know what you're actually going to be dealing with. But if you hear, make a personal website and you're not thinking, oh, I don't know JavaScript, the hell with that. If you're instead thinking something like, yeah, I should be able to duct tape that together, you're probably ready to make a pretty good data engineer, honestly. And so, maybe that's about all I have on, proper slides here and all. But you should be able to get that out there. So
if people are trying to get into big data, one of the things I've used for years is a website, open board called Faker.js. Faker.js is an open source library that it'll generate every type of data that you want. So you can just write simple, you could say I need 1,000 users and with full demographics, and it'll give you real names with real addresses, zip codes.
Real fake addresses.
It's all fake. It has an amazing free capability. So I use that for if somebody wanted to play with big data, you can gin up. You're not going to make a gigabyte table, but you can gin up a couple 100,000 rows locally.
You could. I think I'm taking things over gigabyte just using Java paper.
Can we give you a quick round of applause?
Yep. Yeah, so if anyone's got any questions about particular parts of the industry or more about getting into it or anything.